Hi and welcome to this Solidworks tutorial for a toy ice cream themed Skittles set. This tutorial will show you how to create the basic Skittle and a ball revolve, how to add decals and how to create a motion analysis of the ball hitting the Skittles. The build and alley seen in this rendering is available to download in the description. You'll need this to create the assembly. Alternatively, you can just create a simple flat surface to use as the floor for the analysis. All the decals I'm using in this tutorial are also available to download in the blog description. Starting with a new part, selecting the front plane and sketch. Using the line and from the axis, draw a 120mm line vertically up. Then a 14mm line horizontally from the bottom. Then use the circle to draw a 36mm circle for the top ice cream scoop. Next, use the point and add one point to the top of the circle. You can then hold Shift and select the top point of the line here and make these coincident. It should snap into place. For the second scoop, draw a 48mm circle. And then selecting the midpoint of the circle and the line, add a coincident relation again to snap it to the line. Use Smart Dimension and change the distance between the two centre points of the circles to 30mm like this. For the cone, draw a horizontal 24mm line from this line. Then go down by 9mm and join it back up to the line. Next, add a dimension for the top joining point to the bottom point of the line here, and change this distance between them to 58mm. With that in place, use the Sketch Fillet tool, change the fillet dimension to 4mm, and fillet the two corners of the cone. Then using the spline, starting from the bottom point of the sketch, moving upwards, add a point about here, and join up the spline to the inner point of the fillet. Define the spline, changing the distance between the spline's points to the line by 20mm. Then change the spline's point height to 23.9mm. Finally, using Sketch Fillet again, change the dimension to 2mm and fillet the bottom of the cone and spline. Before I can revolve the sketch, I need to trim away the other halves of the circles here and the inner sketch entities to create this closed profile. I can quickly define my sketch by selecting Display/Delete Relations, then selecting Fully Defined Sketch in the drop-down. Ensure all entities in the sketch is selected for the entities to define and click Calculate. The sketch will then automatically define itself like this. Now I can revolve the sketch along this edge to create the Skittle part. Moving on to the decals, I'm going to start with the cone part of the Skittle. So holding Control, select the bottom face and the filleted edge, and the faces that form the top of the cone. Select the decals icon here, and browse for the cone decal colour, which has been named after the Pantone used to create it, Pantone 2015. When it opens, you will need to go to the Mapping tab and change the mapping type to projection. Viewing the Skittle from the front, change the projection reference to current view so that the decal window is facing the front of the Skittle. To cover the selected faces, you can simply drag the decal window to resize to cover the cone. With that applied, select the main cone face, edit decal, and browse for the cone wafer decal. This time, under Mapping, change the mapping type to Label. Before resizing the decal, untick the Fixed Aspect Ratio box. For the decal's height, change the dimension to 50mm. And for the width, I want it to overlap itself until the pattern joins up. So here I'm trying out different dimensions. At 146.75mm, the pattern matches up nicely, so I can OK the decal like this. For the larger ice cream scoop, select its face, edit decal, and browse for the chocolate ice cream decal. Under mapping, change the mapping type again to label and untick fixed aspect ratio. Change the decal width to 135mm and the height to 38mm, and this should cover the whole face. Now select the top scoop face and edit decal. Browse for the chocolate ice cream top decal and open it. Same process as before, mapping should be on label with fixed aspect ratio unticked. For this decal, the width should be 82mm and the height 40mm. This should cover the whole face. With this decal, it's going to need to be flipped over to fix this issue with the artwork on the top of the decal. So just check the mirror vertically box to flip the decal into place, and it should now look like this. With the first Skittle done, save the part as Skittle 1 but keep it open. To create the 6 different cones, I just changed the top 2 decals of the Skittle and used Save As, changing the Skittle's name each time. To edit the decals, go to the Appearances tab here, select the Decals icon and drop down the Decals list. Right-click the chocolate ice cream decal and choose the Edit Decal option. When this opens, browse for the raspberry ice cream decal and open it. You'll need to input the dimensions for the decal again, same as before. The width is 135mm and the height is 38mm. Do the same for the chocolate ice cream top, replacing it with the raspberry ice cream top decal, and add the dimensions here again. At 82mm for the width and 40mm for the height. Double check that the decal fits all around the face and OK it. Use Save As and save the part as Skittle 2. I repeated this process 4 more times for the vanilla, mint, caramel and pistachio ice cream decals, creating 4 more Skittles. Remember to use Save As you go along and try not to save over the ice cream that you're working on, or you'll have to do it again. Once you have all 6 Skittles, start a new part for the bowling ball. Now this is only a wooden toy bowling set, so the ball is going to be a solid ball with no holes. So sketching onto the front plane, sketch a 65mm circle from the centre of the axis and draw a line down the centre and trim away one of the sides so that you're left with a semicircle profile. Add a smart dimension to the semicircle to fully define it, and this should be 32.5mm. Now revolve the profile to create the ball. To add the sprinkles detail to the ball, select the ball face and edit decal. I'll be adding 2 decals to cover the ball with the sprinkles. The first is the bowling ball decal. Change the mapping type to label. I need to rotate the decal to sit landscape, so just input 90 degrees into the rotate box here. To stretch it to fit, untick fixed aspect ratio and put 121mm for the height so that the pattern matches up but doesn't overlap, and then put 105mm for the height. This should cover the ball completely. To fill in these white gaps on the top and bottom of the bowling ball with the sprinkles, I have a second decal, so select the face again, edit decal, and open the bowling ball top decal. You'll notice that it's a PNG file. The reason for this is that the background of the decal is masked or transparent. When you open it, you'll see that it comes in with a black background, but because it's PNG, we can just select the Use Decal Image Alpha channel, and this makes the background transparent. I'm going to use the mapping on projection for this decal. And looking from the top of the ball, change the reference to current view like this, keeping the aspect ratio fixed and resizing the decal to fit it into the gap. So for this, 40mm fits nicely, and there's no overlapping of the decals on the top or the bottom, so I can OK it. Save the part as bowling ball and start a new assembly. When the assembly opens, you want to start the assembly with the bowling ball alley or your floor. Solidworks should automatically fix the first part you drop into the assembly, but if it hasn't, ensure the bowling alley is a fixed part and not floating. Then, use insert components to bring in your 6 Skittles and bowling ball. Drop in all the parts and place the ball near the middle arrow and the Skittles near the markers. This doesn't need to be exact. I now need to mate all the Skittles to the alley floor from their bases. I am mating them all coincident. When it comes to the bowling ball, this is mated to the alley with a tangent mate. With the parts all mated, look at the assembly from the top view and just drag everything into position. I'm placing all the Skittles above the corresponding colours, but feel free to place them over any. I'm placing the ball just behind the middle arrow and centre to the front Skittle, just like this. With everything in place, I can now begin creating the motion analysis. So selecting Motion Study along the bottom toolbar, change the Motion Study type to Motion Analysis in the drop-down. If this isn't here, you'll need to start it up in add-ins. The first thing I need to do is suppress the coincident mates of the Skittles in the Motion Study tree. Otherwise, the base of the Skittles will stay fixed to the alley floor when the ball hits them and just slide rather than knock over. Keep the ball tangent mate unsuppressed. Now to add gravity. To help the Skittles fall naturally, select this icon and change the gravity direction to the y-axis so that it pulls downwards, and just OK it. Next, we need to add some contacts. This is so that all the separate parts interact with each other rather than falling through each other. So selecting the contact icon, use Ctrl and A to select all the parts. They should all appear in this box. We don't need to change any of the materials for this, so I can just add it to the analysis. Finally, we need to add a force to the bowling ball. Selecting the force icon, select the bowling ball for the face of the force to touch, and for the direction of the force, select the edge of the bowling alley floor here. You may have to flip the direction of the force to face towards the Skittles. I'm keeping the force at 1 newtons as I'd like to try and get a strike with the ball. And then OK it. Because I want the ball to eventually stop rolling and not just keep going, I'm going to turn the force off at around 0.25 seconds. With force selected in the tree and dragging the time bar up to 0.25 seconds, I can right click and turn off the force. A time key should appear like this. To change how long the motion analysis will run, drag the main assembly key along to around 10 seconds. Before you run the analysis, double check the settings here and ensure that the Use Precise Contact box is checked. We can now run the motion analysis. Selecting the Run Analysis icon here, it may take a few minutes to finish, but you'll be able to watch the results as it runs. Once the analysis has finished, you can play it back with the play options here. As you can see, I got a strike. From here, you can export your analysis to Solidworks Visualize, where you can render the analysis as an animation. Here's an animation I created with a motion study. I played around with the camera angles in Solidworks Visualize, and once the animation was rendered, I used some video editing software to slow down some of the parts. I hope you enjoyed this tutorial. Thanks for watching.